Okay, a few things about this first problem. Um, the function is 1/4 to the x minus 5 plus 2. So a few things about exponential functions. Um, when we did parent graphs before, we had the very basic equation, and when it changed, it just shifted or went up and down or whatever. In this case, in exponential functions, the base, because remember the general form is this. But this thing right here, the b part, changes from function to function. So it's not really a parent function in that sense, because that one part depends on the situation. And so in this particular problem, what does b equal? 1/4. It's not a stretch or compression. Okay, that number there in the base position. It's not a stretch or a compression. It's not a transformation in any way. It's part of the actual basic function. So when I say identify the base function, I'm looking for this. 1/4 to the x. And it technically should have had parentheses. That's my bad. All right. And so if I had given you this problem, what's the base function there? 6x. 6 to the x. That it technically should have had parentheses, but I forgot them. I know, but it's just good form. But no, it doesn't. So that would have been, sixes always look like B's. Let's make it an 8. In this case, the basic function would have been 8 to the x. So it's whatever your base is, and then they're called exponential functions because the variable is in the exponent position. And that's why it's called that. So to state the transformations, I do want them in order, right? I want them in a specific order. We talked about the order of transformations before. In this case, I have two transformations going on, a -5 and a +2. Which one should come first? Which one should I take care of first, the -5 or the +2? -5. And whenever it's attached to the x, that means insiders lie. So what does that -5 mean we're going to do? Right 5. Okay, we're going to go right 5. And then we're going to do the +2 next. And when I'm asking for you to graph, there are 3 particular things that I want. I want the horizontal asymptote. That's the same for all exponentials. What is it? Y equals 0. So I want to see this. I want to see that one point that's going to be the same on every basic exponential. Which is that? Which point is that? 0, 1. And the reason why that is the same on every exponential is because no matter what the base is, no matter what we put in there for b, when x is 0, y is 1. And when we have this 1/4 to the 0, y is 1. So that point 0, 1 will be on every single graph. Similarly, there's another point that's not exactly the same, but starts out the same, where x is 1. This is a very easy point to figure out, no math involved. When x is 1, what will y equal? Whatever your base is, right? Because no matter what b is, if you put 1 for x, y will be b. In this particular problem, b is 1/4. So when x is 1 here, y is 1/4. So in case you were looking at your graph thinking, is it, when you were looking at your notes and you were, because I've had several people today, is the graph going like this, or is the graph going like this? You don't really have to have that memorized. You just have to be able to get those 2 points figured out, because then it just determines the direction for you. You have a point at 0, 1, and then this point is at 1, 1/4. So it's clear here that it's the one that goes, it's decreasing. And then we have the horizontal asymptote right there. Okay, that's just the basic function, 1/4 to the x. And then we do the 2 transformations. It's going to go right 5 and up 2. I also want to see your transformed asymptote. Okay, so I want to see these 3 things on both your base function and your transformed function. The asymptote and those 2 special points. Do I want the asymptote on your graphs? Yes. Will I circle it if you don't put the transformed asymptote on your graph? Any questions about these kind of problems before I slide up? Okay. All right, so then down here, find the inverse and then prove it by showing f of -1 to the x. What is that f -1, bless you? What is that? Does that mean f to the -1 exponent? What does that notation represent? Inverse, right? Okay. And remember we talked about how inverse functions are quite literally where the x and y are what? Flipped. Whether you have a table, a graph, or an equation. In this case, we happen to have equations. But I don't have a y here. How am I going to get y into this problem? What's going to get replaced by y? The f of x, right? That's called function notation. It's just another way of naming a function. So I'm replacing that with y. This is the original equation. I'm trying to find the inverse, which means x and y are flipped. So what I'm going to do in this next step is literally take x and y and flip their places. Nothing else changes. No other squares, pluses, divides, nothing's getting inversed except the x and the y. So this becomes x, and that becomes y. And then we just need to solve for y, because solving for the y gives you the new equation. You can start this problem a couple different ways. This is my preferred method, okay? I like to multiply both sides by the 7. So they cancel here, leaving me 7x equals 5 times the quantity y plus 3. And then I like to just divide by 5 here. It's okay if you distribute. It just adds another step or so. I like to do the divide by 5 here. So I have 7/5 x equals y plus 3. And then to get y by itself, I just need to do the minus 3. And instead of putting equals y, what am I going to put here now? The inverse notation, okay? And I will circle it if you don't, because we're practicing this specific skill this unit. I want you to have this in your answer. Yes. Will I circle it if you don't? Yes. All right, so then the next part of the problem was to verify that this works as the inverse, okay? So what you do is you take this and you plug it into the original function. You do math, 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 math. And if you get just x at the end, it means it works, because what's happening is everything is canceling each other out, right? It's inverses of each other. Intuitively, we think we're pretty good because the problem started with plus 3 times 5 divided by 7, and now I have a times 7 divided by 5 minus 3. So it seems like it's probably going to work, but we're just going to do algebra because it's good for us. Okay. So what this notation here means, and I'm going to do a simpler thing real fast before I go back to this one. Instead of f of craziness, if I had given you f of 5, and here's my function, what would you tell me that means I'm doing with the 5? What does that notation mean? X will become 5, right? You take that 5 and you put it right there for x and you simplify. Okay, that's where the input, the x value is a number. But in this case, our input is an entire function. So now instead of 5, what I have in that place is the notation for the inverse, which I just found down here. So instead of putting in just 5 where x is, I'm putting all of this where x is. Okay, that's my input now. It's the whole expression. So I'm going to go back up to the original function and put it just for that one little place where that x is. Everything else is going to stay the same around there. So I've got a 5. I've got a parentheses. Now instead of x, I'm putting my inverse function, which was 7/5 x minus 3. This is replacing x now. And then to keep going, I have a plus 3 and everything over divide by 7. But you have to be careful here, because what you're really going to want to do right here at this step is this. But that is bad math right here, because this entire group of things is being multiplied by that 5. In fact, this entire group of things. So it's 5 times that. So you cannot just be canceling out right here. What you have to do instead is follow your order of operations. You want to simplify the numerator as much as possible using order of operations. So if I'm looking, so that's P first for parentheses. So I'm looking in these parentheses first. There's nothing to simplify there. So I go out to these parentheses. What simplifies here? The 3's, right? Got a -3 and a +3. And those can cancel out. So now after that I have this in the numerator. And now what cancels out? The 5's. Now we can cancel out the 5's, like quite legitly. And then what cancels out here? The 7's. Please understand that you can't just give me nonsense here and then put X check, because I am specifically checking your math here for good math, okay? It's not the answer so much as the proving that it all cancels out accurately, all right? So you may keep this warm-up out for your quiz, all your notes, all your homeworks. Any other last-minute freak-out questions? Okay. Also, well, I'll tell you that again in just a second.